All right, so last time what we described is we described the structure of muscle. So a bone attaches to a tendon attaches to the muscle and connects the muscle to the bone. On the other end, there's another tendon and then another bone. When we contract the muscle, we move the joints closer together, and that's how we move. And then we talked about how the smallest unit of muscle is this thing called the sarcomere. And then what happens was you get this myosin binding to actin, going through the power stroke, bringing in ATP, releasing the actin, breaking the ATP, and providing the energy. And then, if calcium is still there, grabbing on again, and you go through continuous cycles of this power stroke. And now what we have to do is we have to turn that little, very small unit, the sarcomere, into something else, which is going to be a whole muscle that's going to allow us to move. All right, so by the end of this series of lectures or this series of videos, you should be able to explain how the arrangement of sarcomeres alters performance. You should be able to draw and explain the length tension curve, so how the length of the sarcomere affects the tension or the force that sarcomere can develop. You should be able to define pennation and tell me what the benefits of pennated muscles are. You should be able to demonstrate the three basic types of muscle contraction. You should be able to describe the force-velocity relationship. It's very simple. You already all know it, because if you go to pick something up that you think is going to be really heavy and you put a lot of force into it and it's really light, what do? It moves really quickly. So that means lighter things move faster, heavier things move slower, and this is just going to give us a scientific relationship between those two things. You'll be able to define what a motor unit is, and the motor unit is, again, the nerve that we talked about coming from the brain or the spinal cord and going to the muscle. That nerve and all of the muscle fibers that it innervates is what we call a motor unit. You'll be able to compare and contrast the different types of motor units. So we have slow ones, we have fast fatigable, and we have fast fatigue resistant motor units. And all of them have different properties, and you're going to be able to compare and contrast them. You're going to be able to state what we call the Henneman size principle. Again, Henneman was the scientist who described it first. And this basically tells us how we can use the same muscles to do a very fine motion like threading a needle, or a more ballistic motion like throwing a dart or throwing something even bigger than a dart, so that we're now using a lot of force. So, and a lot of that's determined by this thing called the Henneman size principle. And the last thing you're going to be able to do is distinguish between things that we can train. So you're 18 to 22, what can you train today that's going to make you better when you're 19 to 24? Or what are the things that you're stuck with, because these are the things that we can't really change once we're at this 18 to 24 range. All right, so those are the things that we're going to look at, and those are the things that we're going to do over the next little bit.